formaldehyde is a carbon with an oxygen and these hydrogens, and it's also produced by compressor stations. Like nitrogen dioxide, it's a reactive molecule, it's a gas. Now, what I've done here is I've just gone through a simple experiment or comparison. We're talking about a compressor station, but people are building fracked gas power plants all over New England. This is the latest rage. So I'm evaluating a proposal from Rhode Island to build a 1,000 megawatt fracked gas power plant. That's big, right? 1,000 megawatt power plant. That thing is going to dwarf a compressor station. So let's compare formaldehyde. Okay. New Ipswich compressor station. Formaldehyde, 0.64. All right, so now the power plant, 1,450. That makes you feel good, right? We could be worse off. We could be having to deal with a fracked gas power plant like the people in Rhode Island. But I hope if you're paying attention, you might have noticed something here. If I can get my pointer to work, except I think I lost it. All right, look again at these numbers. Oops, hold on. Here we go. 0.64 is actually tons per year. On the other hand, this lower table, which is the one that I took out of a proposal for this 1,000 megawatt fracked gas power plant, is in pounds per year. All right? This is a big difference. So if we actually compare these two, new Ipswich compressor station, if you convert those tons to pounds, 1,280 pounds per year. And that would be released at a stack height of 83 feet. Those are not my numbers, that is taken directly from Kinder Morgan's filing. Again, taken directly from another company's paperwork. This 1,000 megawatt fracked gas power plant, 1,450 pounds per year, except that they're releasing it at over twice the height, at 200 feet. So the difference probably has to do with the nature of the engines that are burning the gas, and potentially the way that the emissions are cleaned up for the formaldehyde. But really the bottom line is, you'd have to deal with almost as much formaldehyde as a 1,000 megawatt power plant. Okay, so this is just a little thought experiment. The battery's dying. Okay. And why is it important? Why am I talking about this today? It's because formaldehyde is dangerous, it's an irritant, it's toxic, it causes cancer. And this sign is actually not up to date. Formaldehyde, the EPA and the Centers for Disease Control has verified that formaldehyde does cause cancer. It causes some cancers of the nose and throat as well as leukemia. And in fact, both the EPA and the Centers for Disease Control have put together expert panels to review the published health literature on formaldehyde, and they've come up with thresholds for human health. And we lost the edge of the slide. For cancer, the lowest limit of formaldehyde that increases your risk for those cancers is 0.08 micrograms per cubic meter. The level of toxicity, or the threshold for toxicity for formaldehyde is between 10 and 49 micrograms per cubic meter. Okay. So now we can, the unfortunate thing is, I want to do the same thing that we did for nitrogen dioxide, but we can't. And the reason is that Kinder Morgan was not required to do a similar analysis for formaldehyde. It's not in the same category of pollutants according to the EPA. So we don't have that information, but what we do have, instead of forecasts or predictions, we have actual measured data from compressor stations. So these are data from a study that measured formaldehyde and other chemicals near compressor stations. And this table are measurements of mostly formaldehyde near compressor stations in Pennsylvania. And one thing I'd like to point out, first of all, is that the samples were taken at a variety of distances, on the order of a few hundred meters, but all the way up to nearly 800 meters. Okay? And that shows you on the right we have the concentration of formaldehyde measured at that distance from a compressor station. So this is one way, we can do the modeling to come up with the concentration, or we can actually measure the chemical to come up with a concentration. So now if we take all of these pieces, we take how much formaldehyde Kinder Morgan thinks they would release, we take what's been measured from a compressor station, we take the geography around the site, we can ask ourselves, what's within 790 meters of the proposed site? I would like you to take a look around, because we are sitting almost exactly 790 meters from the site that Kinder Morgan would like to use for their compressor station. Here you go. Again, just some simple clicks on Google Maps. I think if you're familiar with the area and the site in Kinder Morgan's maps, you would realize the start of that arrow is pretty close to where they're saying the station would go. The other end of that is where we're sitting right now. And you can see up there, 790 meters. Now let's go back and look at the numbers. The measured concentration of formaldehyde, 61 micrograms per cubic meter. The lower limit, lowest concentration of formaldehyde that increases your risk for cancer, 0.08. The lower limit of formaldehyde, the concentration that increases your risk of health effects, and those are things like irritation of the nose and throat, probably nosebleeds and headaches, 10 to 49 micrograms per cubic meter. Some simple math. This 61 is 762 times the 0.08, which again is the lowest concentration of formaldehyde that the CDC and EPA have said increases your risk for cancer. And it's between 1.25 and 6 times the concentration of formaldehyde that increases toxic effects. I think the value of this information is simply putting the pieces together. I don't think the logic is particularly confusing. This is just putting together what we know. Now, what you could say is, if you really know a lot about these cancer thresholds, what you can say is, well, the risk is really low. You're talking about 1 in 10,000, 1 in 100,000, 1 in a million people. And these are, if you're exposed over a very long period of time, and we're not talking about like, you come here to the school for the day and you go home, You can make those arguments. But at the same time, let me ask you this. Ask yourself, after looking at these numbers, what is the increased risk of cancer that you find acceptable for your children? And it's whether your children come here, your neighbor's children come here, some other family's children come here, what's acceptable? I don't want anyone to raise their hand, but if you were a childhood survivor of cancer, your child had cancer, God forbid, you know a child who had cancer. As a pediatrician, during my training, I took care of a fair number of children with cancer. Some of them were cured, some were in remission, and some died. And let me tell you, my stance, my professional opinion, what is the acceptable increased risk of childhood cancer? The answer to that is 0. There is no acceptable risk of increased cancer among children. And that's just the starting point. That's only looking at this school. There are more things. People live around here. This was 61 micrograms at a distance of 800 meters. We don't know. These are the best data we have about formaldehyde. All right? I showed you a few slides ago. There's a lot coming out of compressor stations, but we haven't done enough research to understand how far out do you have to go before you get to that 0.08. Is it a mile, 2 miles? We're sitting at a half a mile here. How far do you have to go? How many people are living in that distance? That's something we don't know. Okay, now to get back to the talk, we talked about nitrogen dioxide, we talked about formaldehyde. And I think from the things I've said so far, hopefully it's clear why these two are particularly important for people living in this community. So we saw a small version of this table that had the nitrogen dioxide. I cut it up, but now I'm showing you the whole table. And the reason I'm showing it is because some people might say, well, you know, I've read about compressor stations, what about the particulate matter, volatile organic compounds? So, you know, we can look at this, we could be reassured, right? Particulate matter, it's quite toxic. I didn't go into the details, but it's quite harmful to human health. Again, there's this annual average, a 24-hour peak, and these are the significant thresholds. And, you know, fortunately, we can all feel good, right? Because Kinder Morgan's consultant told them, don't worry, the change in particulate matter is going to be well below the significant threshold. Okay, well, you know, if that's true, we can do a head-to-head comparison between the compressor station Kinder Morgan would like to build and a compressor station that Spectra Energy would like to build in Weymouth, Massachusetts. This is another project that I've been looking at. We can do a head-to-head comparison and see how they stack up. So let's walk through this. The turbines. Weymouth, Solar Taurus 60. New Ipswich, the Solar Titan 130, and you get two of those. If Kinder Morgan has to, right? So the horsepower in Weymouth, 7,700 horsepower. Don't be fooled. Spectra Energy has already submitted paperwork to expand the compressor station that has not even been built. All right, so if you've ever asked yourself, are they ever going to go back to that 80,000? That's entirely possible. It happens all the time. And Spectra is right now about to finish an expansion on a compressor station in Rhode Island. So that certainly happens. All right, so, but you could say, well, 7,700, 42,000, more or less. It's about, what, 5-6 times the size? Okay. And Spectra said, well, we're going to put out about half a pound of this toxic particulate matter an hour. And not surprisingly, Kinder Morgan has said, well, we'll put out maybe 5 or 6 times the amount of toxic particulate matter an hour, 2.2 pounds. And then in a given year, of course, Spectra Energy has said about 2 tons a year. In New Ipswich, Kinder Morgan has said, well, we might do about 4.5 times that, 9.2 tons. And then the initial phase of the Weymouth compressor station is at the same point as Kinder Morgan's now, so we have the same kinds of numbers, these 24-hour peak particulate matter numbers. Spectra Energy has said, okay, we're going to go up, the local levels are going to go up by 3.2. And Kinder Morgan has said, ours are going to go up 4, 5, 6, 7 times that. What do we see here? No, their consultants told them, no, actually, you're in luck because your compressor station may be 7 times the size, but fortunately, it's going to release 1/9 less particulate matter, right? So this goes back to what I said earlier. We can use the numbers that Kinder Morgan is producing, and we can come up with arguments that are very compelling in terms of the risks to human health. But we shouldn't stop there. We have to also do this kind of work and ask ourselves, do we really believe these numbers? There are some groups, these are data from, again, the Southwestern Environmental Health Project. They've been trying to measure levels of particulate matter, which again, it's toxic, it's produced by compressor stations. And they're trying to collect their own measurements and actually find out what's coming out of the compressor station. What's the concentration that local people get exposed to? And the only thing I'll say is that these wouldn't be, you couldn't call these like finalized numbers in terms of like the EPA. It's not done with one of the very expensive measurement devices, but it's a starting point. And what you see are these numbers. The distance from the compressor station is between 0.5 kilometer and 1.5 kilometers, so about 2 miles. And these are an average concentration over 2 months. And so this might correspond to like an annual average, for example. And I can tell you the annual average for places like southern New Hampshire, western Massachusetts, even Worcester and Providence, the annual averages in particulate matter there are on the order of 6 to 8 micrograms per cubic meter. And you're looking at 14 and 20. So, you know, we're really struggling to try and understand what the real concentrations are. We're doing the best we can. The preliminary data we have, I think, are very concerning. And I'm doing something similar in Rhode Island, and I'm really seeing the same thing there. Okay, so in terms of the specific air pollutants and how they might affect human health, that's as much as I have to say right now, and I'd like to get into some other issues. And the first is, these, to me, they seem like some pretty serious allegations. Why haven't they been addressed in the pipeline approval process before now? And there have been a lot of pipelines approved by the federal government. Why hasn't this been brought up? Why hasn't this been addressed? Well, for starters, let's look at what actually goes into one of these applications. These are thousands and thousands of pages long. We're not going to go into that, but we're going to look at this summary of what's actually in it. This is, again, from Kinder Morgan's final application filing last month. And what I've done here is simply copy out some of their summary sections. And this is from their environmental report, Resource Report 9. And this is the section dealing with air and noise pollution. And this brings up a good point. Everything we're talking about is simply air pollution. It's not that noise pollution is not important. That's a huge topic in and of itself that we just can't get into tonight. But out of the sections that deal with air pollution, we have describe the existing air quality, section 9.1.1. That's important, okay? They did that. That was addressed. Quantify existing and proposed emissions of the compressor and anticipated air quality impacts. Now, whether we believe them or not, they did do that, and we looked at some of those numbers. And then this last section, 9.1.2, describe the horsepower, type, energy source, all this technical stuff. Okay, they did that too. That's it. That's a summary of the sections of what's in their filing application. All right? So what's missing? How about the part of the application where they describe the size and demographics of the population in the vicinity of the proposed compressor station? Wouldn't you like to know that? Don't you think that should be in that application? And how about this? What we've been talking about all night. Estimate the health effects of air pollution on local populations. Which section is that in? And finally, the one thing I would like to see in there, describe what actions you're going to take to mitigate, remediate, or compensate for the resulting health effects of your project emissions. Okay, why don't we have those in there? I do want to bring up one point that I think is very important, and that has to do with regulatory standards. The EPA uses different sets of regulatory standards to evaluate projects like this. That 49 versus 50 cutoff I mentioned, that helps them avoid some of that issue. But they do have to stick by this NAAQS. This is the National Ambient Air Quality Standard. And this is how Kinder Morgan has to address public health. And the reason is that these standards are set by the EPA, and the goal of those standards, their primary purpose is to protect human health. But what's actually in those standards, I've shown at other presentations the standards about particulate matter, but here what I'm showing, because we talked about this nitrogen dioxide, what are the standards for nitrogen dioxide? The EPA has said this 1 hour peak should never go beyond 188 micrograms per cubic meter. And from Kinder Morgan's point of view, that's great. The maximum peaks right now are 37. And with the additional emissions from our station, we would be looking at, the highest would be 48.6. Okay, that's a lot lower than 188. How are you going to get the EPA to care when you're telling them, well, the project is going to be so far below your own regulatory standards that are designed to protect human health? Okay, but then I just put back up the information I showed you based on those public health studies. This is really easy. You can go online, you can find the summaries, the short summaries of these studies. They all say this. A change of 10 micrograms will lead to this. That's the standard approach for all of these hundreds, if not thousands of studies. So really what we're looking at is quite a disconnect between the standards that are supposed to protect our health. And to some extent, maybe they do now or in the past, but the EPA comes under a lot of pressure, both from politicians and from industry, and they're not reviewing these things every year. I mean, a lot of the research coming out has been in the last year or two. So there's a real disconnect between the requirements that Kinder Morgan has to meet to get this project approved and what's actually going to affect human health. So I've covered most of our points for tonight. We'll try to wrap up. Hopefully we've done a reasonable job addressing what comes out of a compressor station and whether those emissions are harmful, as well as whether people living next to compressor stations experience some health symptoms. Not a lot of data, I admit, but hopefully more to come. And then the most important thing, would emissions coming from a compressor station here be harmful to human health in southern New Hampshire? So I want to go back and address a few more points. And the reason is, for me, health is a very important topic, obviously. But when you go out into the broader world, people talk about other issues related to these pipelines, and a lot of them really do affect health, human health in general, and child health as well, in indirect ways. And so I just want to put up a couple of slides. First of all, this is a slide related to this fracked gas power plant that I mentioned in Rhode Island. It's being built really right next door to an existing compressor station that's going through an upgrade. And those are right on the natural gas or fracked gas pipeline right next to a power plant. Or not a power plant, power lines, high tension power lines. Right? And what are we looking at here? This is exactly the scenario that would be created by this pipeline. A compressor station, a fracked gas pipeline, and high voltage power lines. We don't know where they're going to build the next fracked gas power plant. There are several of them that are either being proposed, and if not under construction in New England, because even though Massachusetts already gets over half of our electricity from burning fracked gas, there are a lot of coal plants and nuclear plants that are being retired. And a lot of people see this as a way to introduce fracked gas, because we need to have something else to replace those dirty fuels. So instead we can replace the coal plant with a clean fracked gas power plant. And again, like I said, this is for a plant in Rhode Island that's being proposed. And these are the tons of emissions that would come from a clean power source, okay? Over 200 tons of nitrogen oxides, carbon monoxide, 200 tons of particulate matter, 3.6 million tons of carbon dioxide, which leads me to another point. I think we've all heard by now, clean natural gas is a bridge to a clean energy future as we get away from the dirty coal, right? Well, if you only look at this yellow here, this is a figure from a report by the environmental scientist at Cornell, who's done a lot of work to evaluate emissions in the power sector. If you look at the carbon dioxide emissions in yellow from coal, yeah, there's a lot more carbon dioxide produced compared to natural gas. And that's what gas companies love to point out. The carbon dioxide emissions from our clean gas are so much lower than coal. And people who are in favor of pipelines and power plants, they'll say the same things. But what this report highlights is all of the research that's been done to highlight the greenhouse effect of methane, which is a much more potent greenhouse gas than carbon dioxide, and at this point is probably as strong at driving climate change as carbon dioxide if you read these reports. And so the red sections here are, if you were to convert the methane effects and make it so you compare apples to apples, what this sidebar says is carbon dioxide equivalents produced per millijoule of electricity. So basically, if you translate the methane effects into carbon dioxide effects, and you produce electricity both ways, how much pollution is produced? And, if anything, burning fracked gas to produce electricity will do more to damage the climate and advance climate change than burning coal. And that's because, we started talking about gas in the 2000s maybe, as we started to frack more and more, but the more research is being done, the more we realize this is a very bad idea for the climate. And why am I talking about climate change? And for that matter, why is a doctor up here talking about compressor stations anyways? I'm not on a fringe. There are a lot of other doctors who think like me, and in fact, the American Academy of Pediatrics, in September of this year, 2015, released a new policy report on climate change. And they released a number of policy recommendations for pediatricians